All right, everyone. Today we're going to talk about compound inequalities. And a compound inequality is when you have two or more inequalities combined into one. Basically, we're going to do two. Two different inequalities, we're going to combine them into one. Now, one way to do it is actually just using the word and or the word or. So you can say like this inequality and that inequality, and you've combined two into one. Or you could say this inequality or that inequality, and you've still kind of combined two into one. So one thing I could do is I could say x is greater than or equal to 3 and x is less than 14. That's an and compound inequality. Or I could say x is less than -2 or x is greater than or equal to 4. Now one thing you notice, or one thing you want to notice, is the and inequality, you have to have a situation where both of them could be true. So for example, for that first inequality, I could say, let's say I was talking about the number 10. The number 10 would work for that because 10 is both greater than or equal to 3. 10 is greater than 3, but it's also less than 14. So what you're doing is you're kind of saying like the number between those two. If you say x is greater than or equal to 3 and less than or equal to, or less than 14, you're talking about the numbers between 3 and 14. But if you look at the second one, if I say x is less than -2, you have -3, -4, -10, -100, you have all these negative numbers, none of them can be greater than or equal to 4. So there is no one single number that's going to be both less than -2 and greater than or equal to 4. And that's why it was an or statement instead of an and. Okay, so the and inequality, because you're talking about one series of numbers that is both things, you can actually take those two and combine them into one. So let's take a look at the one we just talked about. We had x is greater than or equal to 3 and x is less than 14. Now if I wrote it this way, 3 is less than or equal to x is less than 14. If you look at it, what I've actually done is two things. I'll start with the second one because it's easier to see. X is less than 14, that's the second half of this inequality right here. So like if you cover up the first part, the 3 and the less than or equal to, what you see is exactly what we want to see. X is less than 14. Now, the other part of this one is actually this thing right here, but written backwards. So instead of saying x is greater than or equal to 3, we're reading it backwards and we're saying 3 is less than or equal to x, but that's the same thing. So by taking the first inequality and writing it backwards, instead of x is greater than or equal to 3, we write 3 is less than or equal to x. We can then just stick those two x's together and make one single, this is what we call a compound inequality. More than one inequality, two combined into one. We twist the first one around so the x is on the right instead of the left, and then we just put the x's together and make it one. Now, the or inequalities, don't do that for them, because remember, you're not saying there's one single x that is this or that. It has to be separate. So any of the or inequalities, you leave them exactly as we had written before, this thing or that thing. But the and inequalities, you can combine into one. So let's talk about how to solve them, and I'll start with the or. To solve an or inequality, very simple, just treat it as two separate problems. Solve each part separately. When you get your two answers, those two things together are your answer. Now, to solve the combined and inequality, so when you have the compound inequality, where like ours was -3 is less than or equal to x is less than 14. What you want to do, solve for x in that middle part, but just remember, normally when we solve an equation or an inequality, when you're solving for x, anything you do to two sides. Well, this time we're doing it to all three parts. So like if I want to solve for x by adding 10, instead of saying I'm going to add 10 to both sides, I'm going to add 10 in 3 places because I have a 3-part inequality here. But if you do that and you solve for x in the middle, you'll see that you've solved. So let's do an example of each one. And for our first example, let's do one of the or statements. So we have an inequality, 3x is less than negative 6, or 2x minus 5 is greater than or equal to 7. And I said, just think of it as two separate problems. Solve each one. So let's start with the 3x is less than negative 6. And I'm going to say, I'm going to solve this just like an equation. I'm going to kind of split my inequality down the middle. I can do anything I want, as long as I do the same thing to both sides. Just remember, just like we said in the first two sections of this module, if I divide or multiply by a negative, it's going to flip that inequality. Now, I don't have to do that for this one. I can do this one in one step. I think I just need to divide both sides by 3. Cancel out that 3 there, leaves the x, leaves the less than, because I didn't divide by a negative. Negative 6 divided by 3 is negative 2. So there's the first part of my answer. X is less than negative 2. Now let's do the same thing on the second part. I'm going to split my equation right here at the greater than or equal to, and I'm going to solve for x. So I think what I would do first is add 5 to both sides. Cancel that one. It leaves the 2x, it leaves the greater than or equal to, and 7 plus 5 is 12. And then we'll finish it off by dividing by 2. Those 2's cancel. I'm going to leave the greater than or equal to. I still didn't multiply or divide by a negative. And 12 divided by 2 is 6. So those two things together with the word or between them are my answer. I would say my answer is, I'll write it out here, x is less than negative 2, or x is greater than or equal to 6. Now the second thing I asked you guys to do is graph it. Now remember, we're graphing on a number line. So let me draw in a number line. I'll put a 0 in the middle. I don't think I need to scale it. I'm counting, I have a negative 2 and a 6. I can probably just count by ones. So we have 1, 2, 3, 4, 5, 6 here. We have negative 1, negative 2 here. And I'll count a few more points to fill in my number line. Now do each one separately. So the first one was at negative 2. It's a less than without the equal to. So I'm going to do an open circle on negative 2. And less than is to the left. So I'm going to shade all these numbers over here on my number line. And I'm going to say my answer is everything to the left of that open circle. All of those. But then I have a second thing. I want to graph that too. So here we have x is greater than or equal to 6. So on the 6, this time, because it did have the or equal to, I'm not going to put the open circle. I'm going to fill it in, put what we call the closed circle, or basically a dot. And this time I'm looking for x is greater than 6. That would be to the right. So I have all these answers over here that I'm going to shade in. Darken that. Now this is what an or should look like. When you graph an or statement, a compound or inequality, you should have two separate pieces moving away from each other. One is a less than, one is a greater than, but you have like two separate pieces moving away from each other with an empty spot in the middle. All right, let's try the second example, the other type of inequality, the other type of compound inequality. All right, so let's say I ask you guys to solve and graph this equation right here. Negative 19 is less than or equal to 3x minus 2, which is less than 13. So this is that one where I said we have three parts to this. I'm going to put a dotted line under the less than or equal to, and also one under the 13. Now my goal is to get that to be just x in the middle. Anything I do, I have to do in all three parts, but don't worry about the outsides. That'll take care of itself. Let's just worry about canceling the things around the x in the middle. So the first thing I want to get rid of is the minus 2. I'm going to use a plus 2. Now remember, for this type of question, if you do anything like a plus 2, you have to do it in 3 spots. So I'm going to do a plus 2 over here and a plus 2 over here. Okay. The 2's cancel in the middle. Over here, we have negative 23 plus 2 would be negative 21. We leave our less than or equal to. We have just a 3x in the middle now. We leave our less than, and 13 plus 2 is 15. All right, one more step. If I want to turn that into an x in the middle, I need to divide by 3 to cancel that 3. Now remember, if I want to divide by 3, I have to do that in 3 different places, the beginning, the end, and the middle. So let's see what we end up with here. Negative 21 divided by 3 is negative 7. We'll leave the less than or equal to. The 3's cancel in the middle, we get the x. We'll leave the less than, and 15 divided by 3 is 5. Now that is my final answer. Maybe I'll rewrite it just to make it look a little cleaner. We have negative 7 is less than or equal to x, which is less than or equal to 5. Now when I go to graph this on a number line, let's count by ones again. One of my numbers was 1, 2, 3, 4, 5. And the other one was negative 1, 2, 3, 4, 5, 6, 7. 7 right there. Now when you're graphing one of these, remember when we did the OR statement, I said you got your 2 points and you're always shading away from each other. The AND statement is going to be shading in between those 2 points. You have, like when I say negative 7 is less than x, which is less than 5, what I really mean is x is the numbers in between negative 7 and 5. So this is how I'm going to do this one. The negative 7 has the or equal to on it. We have negative 7 is less than or equal to x. So I'm going to do a closed circle or a dot on the negative 7. The 5 does not. The 5 does not have the or equal to. We just have x is less than 5. So I'm going to do an open circle there. And you got to be careful with those. Every question is going to be different. You might have 2 closed, 2 open, or you might have one of each like this. Just look at the sign connecting the number to x, and that's how you decide. Now, because it was an AND statement, I'm just going to shade in everything between those. I'm going to color in all this here to show on my number line that the answers are all the numbers that are in between negative 7 and 5. It can be negative 7, that's what the dot means. It cannot be 5, it stops just before it gets to 5. That's what the open circle means. But now you guys know how to solve a compound inequality. There's 2 types, the AND the OR. And you know how to graph each one. The OR, you always have 2 separate lines moving away from each other. The AND is the opposite. You got your 2 endpoints and you're connecting them. You're coloring in or shading between the 2 points.